Today we'll be showing if the span of vectors is a subspace of V, where V is a vector space over a field, and each vector is in the vector space. And to start off, we will recall the definition of span. So the span of a set of vectors V1 through Vn is the set containing the sum from 1 to n of Ci, Vi for each Ci in a field F. And to show that the span of a set of vectors is a subspace, the first condition we have to show is that the zero vector is in the span of V1 through Vn. So to show that, we could let each Ci in the field equal to 0. Then this means we have the sum from 1 to n of 0 times Vi, but that's going to equal to 0 V1 plus 0 V2 plus plus 0 Vn, which is equal to 0, and that's an element of the vector space V. So that means that 0 must be in the span of V1 through Vn. And now the second property I have to show is that A plus B is in the span of V1 through Vn, where A and B are in the span. So if we let A and B be in the span of V1 through Vn, then we have that A could be defined as the sum from 1 to n of AI Vi, and B is the sum from 1 to n of Bi Vi. So if we add these two together, we have A plus B is the sum from 1 to n of AI Vi plus the sum from 1 to n of Bi Vi. And because the indices match, we could turn this into a single sum. So we have A plus B is the sum from 1 to n. We have AI Vi plus Bi Vi, but that's just the sum from 1 to n of AI plus Bi times Vi. So by the definition of span, then this means that A plus B is also in the span of V1 through Vn. And now the third property we have to show is that for some, let's say lambda in the field, then we have that lambda times A is lambda times the sum from 1 to n of AI Vi, but we could bring in this scalar inside the sum. So this is equal to the sum from 1 to n of lambda AI Vi. So again, by the definition of span, this means that lambda A is in the span of V1 through Vn. So now the conclusion is, since all of the following subspace conditions hold, and the conditions are that the zero vector is in this span, and that it's closed under addition, and it's also closed under scalar multiplication, then the span of a set of vectors v1 through vn is a subspace of V, where V is a vector space over a field F. And so that is what we wanted to show.